This section deals with how we multiply two radicals together. The two radicals we're going to start with are 2 root 7 and 3 root 5. Now, when I multiply radicals together, I can multiply numbers together or the coefficients together. So 2 times 3 is going to give me 6. And once I've done that, then I can multiply the two radicals together. So root 7 times root 5 is going to give me root 35. Now if I quickly check the prime factors of root 35, I find that they're 5 by 7. There are no perfect squares that I can pull out of this, so that is in fact in lowest terms. A more complicated example would be if I'm multiplying a binomial together with another binomial. Now there's a couple of ways I could do this. One is I could use a method where I multiply everything in the first bracket by everything in the second bracket. So if I multiply 2 root 3 by another root 3, I'm going to get 2 root 9. Then I need to multiply my 2 root 3 by a root 2, and I'm going to get minus 2 root 6. Now I'm going to move to the 3 root 2. 3 root 2 times root 3 is going to give me 3 root 6. And then finally in my last term, I've got negative 3 root 4. Now I'm going to simplify my radicals. We know that the square root of 9 is just 3, and the square root of 4 is just 2. So I'm going to multiply these two numbers together. So I've got 2 times 3 is 6, minus 2 root 6, plus 3 root 6, and then 3 times 2 is another 6. So my final step, collecting like terms, I've got 6 minus 6 is going to give me 0. Negative 2 plus 3 is going to give me just root 6. So when I'm multiplying those numbers together, your first step is to multiply everything out. Your second step is to simplify any of your radicals, and your final step is to collect any like terms. Another way that you could solve this equation is using the square method. So if we draw a square, we are going to put the first term on the top of the square. So we've got 2 root 3 and 3 root 2. And we're going to put the second term going down the side. So we have root 3 and negative root 2. Now when we multiply, we've got 2 root 3 times root 3 is going to give us 2 root 9. 3 root 2 times root 3 is going to give us 3 root 6. 2 root 3 and negative root 2 is going to give us negative 2 root 6. And finally, we've got negative 3 root 4. So if we write this all out, we've got 2 root 9 plus 3 root 6 minus 2 root 6 minus 3 root 4. Root 9 is a perfect square. That's going to give us just 3. And root 4 is a perfect square. That's going to give us 2. So we can simplify this by going 2 times 3, which is going to give us 6. Root 3 root 6 and negative 2 root 6 is going to give us positive root 6. And 3 times 2 is going to give us negative 6. Our final step is just collecting our 6's. 6 and negative 6 is going to cancel out, and we are going to be left with positive root 6. Finally, if I'm dealing with a variable, we can solve it the same way. So I'm going to multiply these together, and I've got 12 root a squared. Then I'm going to multiply the 3 root a and the 5 together, and we can only multiply numbers together with numbers. We can't multiply them together with other roots. So this one's going to give me 15 root a. Then my inside one is going to give me negative 8 root a. And finally, the last is going to give me negative 10. Now one thing we need to remember is if I take the square root of something that's squared, it is just going to give me that letter. So the square root of a squared is going to simplify to 12a. The square root and the squared, the exponent, are going to cancel each other out essentially. They're opposite operations. Then I collect my like terms here. 15 root a and 8a. We've got 7 root a. And finally, the negative 10 doesn't go anything. Now it is also important to indicate here that a must be greater than or equal to 0, or our term 7 root a would be undefined. So we do need to indicate that all of our values of a must be greater than 0.